Ever get that feeling like what you see isn't the whole picture? Like there's something else going on underneath, hidden in plain sight?
Oh, absolutely, like a secret world. Invisible unless you know where to look.
Exactly. And today, we're diving headfirst into one of those worlds, the world of invisible code vulnerabilities.
And these aren't theoretical, by the way. We're talking real-world security flaws.
Right, this is cutting edge stuff. Researchers from, get this, the University of Cambridge uncovered this. They call it, are you ready for this? Trojan source.
Catchy name, right?
It really is. But we're talking about vulnerabilities hidden literally within the lines of code that, well, make our digital world go round.
And what's wild is that this isn't some crazy complex thing.
Yeah.
It exploits how code is written at a really fundamental level, how we read it, how computers interpret it. It's kind of brilliant in a scary way.
Okay, so Trojan source, it's hiding vulnerabilities. Got it. But how can code be invisible? I mean, it's right there on the screen.
Okay, imagine this. You're reading a message. Seems normal, right? But hidden in that message are secret instructions. Invisible to you and me, but someone or something with the right tools, they see those instructions perfectly.
Okay, I'm intrigued, but I'm not seeing the code connection yet.
So instead of invisible ink, we've got Unicode.
Unicode, like emojis and stuff.
You got it. Emojis, but way more than that. It's how computers understand and display all those different writing systems.
Mm-hmm.
English, sure, but also like Mandarin, Cyrillic, you name it. Without Unicode, the internet would be a whole lot less interesting.
Okay, yeah, that makes sense. Global communication and all. But how does that turn into a security risk? Where's the Trojan part come in?
Ah, good question. So there's this thing called BD, short for bidirectional text.
Okay, I think I've heard of that.
Right, so some languages like Arabic or Hebrew, you read them right to left, yeah. English, we go left to right. BD helps computers display both those ways on the same page, without everything getting jumbled.
Yeah, I've definitely seen that on websites.
Exactly. But here's the thing, and this is what blew those researchers' minds. BD uses these invisible control characters to tell the computer how to display the text. Usually they're totally fine. But they realized those characters, you can manipulate them.
Manipulate them how?
You can change how the computer understands the code without changing how it looks to us.
Wait, so the code, it can look different to me reading it than to the computer actually running it.
That's it. Think of it like this. A compiler is like a translator. Takes our code, which humans can read, and turns it into something a computer gets. Trojan source, it messes with that translation using those hidden BD characters.
So I might think a line of code does one thing, but because of these hidden characters, the compiler sees something totally different.
Exactly. And boom, you got yourself a Trojan horse hiding right there in your software. Sneaky, huh?
Okay, my head is spinning. So we're talking like digital trickery, but with, potentially disastrous results. Can you give me an example? Like, how does this Trojan source thing actually work in real life?
Okay, so imagine you're looking at some code, right? Python, let's say. It's supposed to handle, like, a financial transaction, taking money out of a bank account.
Yeah, pretty straightforward, right?
Should be. But with this Trojan source thing, an attacker could hide something called a BD modified return statement, all hidden within what looks like a normal comment.
Okay, hold on. Return statement. ELI5. Explain like I'm 5.
Right. So a return statement, it basically tells a function, like a chunk of code, to stop running. Imagine a worker just clocking out early.
Sneaky. So the code, it looks like it's taking the money out, but
it hits that hidden return and just stops. Money never moves, but you look at the code, seems totally legit.
that is both brilliant and terrifying at the same time.
Yeah.
Are there other ways to pull this off besides this whole, what was it, return statement thing?
Oh, yeah. The researchers, they found a bunch of ways. One's called commenting out. This one's all about making stuff disappear.
Disappear how?
So let's say you've got some important security check in your code. Like if the user is an admin, then grant access. The important stuff.
Yeah, don't want just anyone messing with admin privileges.
Exactly. But using Trojan source, an attacker can make that whole check, that whole line of code, look like just another comment to the compiler.
A comment meaning like a note for humans, the computer ignores it.
Bingo. So the compiler, it just skips right over that crucial security check, thinks it's nothing, and boom, access granted, admin privileges for everyone.
Like making a stop sign invisible to a self-driving car.
Yeah.
Recipe for disaster.
Perfect analogy. And then there's, this one's clever, stretch strings. It messes with how the computer compares things. Like, imagine checking if a password matches, right?
Yeah.
Attacker can use these BD characters to make part of the code look like it's not part of that comparison, but it actually is.
So the computer gets tricked, thinks the passwords don't match, even when they do.
You got it. And because this whole thing, it plays on how programming languages actually work, it's really hard to spot without the right tools, like trying to find, I don't know, a chameleon that's perfectly camouflaged.
Okay, this is getting a little too real for me. How widespread are we talking here? Is this just like some obscure coding languages, or is this like the stuff we use every day?
That's the scary part. This Trojan source thing, it affects a ton of languages. C, C++, Sin, JavaScript, Java, even Solidity, which is for those Ethereum smart contracts.
So basically everything.
Pretty much. This isn't some small-time vulnerability. This could be in operating systems, web browsers, financial apps, even the blockchain.
Not what I wanted to hear.
It does make you think, right? Like, whose responsibility is this? Should it be on, I don't know, the people making compilers to stop this? Or the coders themselves?
Sounds like an all-hands-on-deck situation.
Definitely. Good news is, once the researchers sounded the alarm, a lot of the big companies, they sat up and took notice. Like GitHub, where everyone stores their code, they're working on defenses, trying to make those characters visible, so we can actually see them. Some companies even offered those, what are they called, bug bounties?
Cash for finding vulnerabilities.
That's the one, averaging over $2,000 a pop, some of them.
Well, good to know someone's taking it seriously, but it feels like we're always going to be playing catch-up. Find one thing, another one pops up.
It's true. And honestly, this Trojan source thing, as wild as it is, might just be the tip of the iceberg, especially once you factor in artificial intelligence.
Wait, AI is involved in this too. Hold on, how?
Oh yeah, this is where it gets really interesting. See, Trojan source, it works because of how we read code, right?
Yeah.
Humans, AI, it doesn't see code the way we do.
So it wouldn't be fooled by these tricks. It could see the hidden stuff.
Exactly. Which you'd think, great, right, problem solved. Except it kind of opens up a whole new set of problems.
Oh no, how so?
Think about it. If these AI chatbots, right, if they're reading those hidden characters, what's to stop someone from sticking malicious instructions in the data the AI is using?
You're blowing my mind again. So wait, are you saying that AI could actually become like a weapon, like tricked into running bad code because it's hidden in the data it's trained on?
Not exactly like AI going rogue or anything. It's more that there are these new ways to exploit it, Remember we were talking about prompt injection before?
Remind me about that.
Okay, so imagine you're using, I don't know, Microsoft 365 Copilot.
Yeah.
You ask it to do something easy, like summarize an email, right?
Yeah, totally. Seems harmless.
It is. Except think about it. That email, it could have those invisible Unicode characters hidden in it with instructions, And there's this researcher, Johann Rehberger. He actually showed how this could work.
What did he do?
He created these, like, test attacks. He got Copilot to leak info, like secret sales numbers, even one-time passwords, all thanks to those invisible characters hiding in plain text.
Hold on. So he could basically make Copilot do whatever he wanted just by hiding code in an email.
Pretty much. The AI, it'd follow those hidden instructions, pull the data, and then, get this, it would even, like, hide it in a URL using, you guessed it, more invisible Unicode.
So you'd click the link and boom, all your data's gone.
Exactly. And you'd never suspect because the link, it looks totally normal.
That is like seriously messed up. Did Microsoft fix it?
So the guy, Rehberger, he told Microsoft about it. And to their credit, they did do some stuff to try and stop it in the new Copilot. But it makes you wonder, right? What about ChatGPT or Google's Gemini? Are they vulnerable too?
I was just thinking that. What about those?
It's weird, right? OpenAI's API and Azure OpenAI API, they were reading and writing those characters for a bit, but then they just stopped.
No explanation.
Nope. Nobody knows why, really. Maybe they're working on it. Who knows? But the ChatGPT website, at least for now, it seems like it's a bit better at handling those invisible Unicode things.
So is Gemini okay then?
Gemini's a tough one. It can read and write those hidden characters, but it doesn't always seem to, like, get that they're commands. Or it's not consistent about it, at least.
So it's like constantly changing, this whole thing.
It really is. Just when you think you've got a handle on things, something new pops up.
That's a little unsettling, to be honest.
Yeah. It just shows that with AI, security's a whole different ballgame. We need to think it differently. Because as AI gets, smarter, more ingrained in everything we do, We got to be way more careful with the data we're giving it.
Even stuff we can't see.
Especially that. It's like we need almost new eyes, digital eyes, to
Yeah.
really get what's going on.
Okay, so what now? Like, I'm not a coder or anything, but this whole conversation has got me thinking, what can I do to protect myself?
Honestly, just knowing about this stuff, that's a huge first step.
Yeah.
And you're already there. But yeah, be careful about copy-pasting code, especially if you don't know where it's from.
Makes sense.
And this might seem obvious, but be extra careful about clicking links from AI, even if it's one you trust.
So trust no one, basically, not even code or AI.
It's not about being paranoid, really. It's more just being aware, right? Like, if you were messing around with code, even for fun, just take a second to look it over, especially in the comments. And those strings, remember, might save you a lot of trouble later on.
This whole deep dive has been like a wild ride. It's like we went behind the scenes of the digital world, saw all this crazy hidden stuff.
Yeah. It really shows that in software, things aren't always what they seem.
And as we all use more code, understanding those vulnerabilities, it's more important than ever.
Couldn't have said it better myself.
Well, on that note, I'll leave our listeners to mull that over. This was awesome, really eye-opening stuff about these invisible code vulnerabilities.
It really was fascinating.
Until next time, everyone, stay curious, stay safe, and remember, what you see might not be what you get.